Hi, welcome back to Easy Math with Dr. Nasir, your path to math confidence. I welcome you to my whiteboard for grade 9 to grade 12 students. Well, our today's topic is the real number system R. Counting starts from 1, denoted by 1, and subsequently we define 1 plus 1 to be 2, denoted by 2. We define 2 plus 1 to be 3, denoted by 3, and so on. Thus, a set consisting of counting numbers 1, 2, 3 is known as the set of natural numbers and is denoted by n. Therefore, n is defined as set consisting of elements 1, 2, 3 and so on. In science and engineering, we need zero and negative numbers, for example temperature of a lab or a quantum computer. Therefore, we define the set Z to be 0, 1, 2, 3 and so on, minus 1, minus 2, minus 3 and so on, which is called the set of integers. In real world applications such as in science, engineering, economics and finance, the set Q is defined as P by Q, where P and Q are integers and Q is non-zero, is of significant importance and is known as set of fraction numbers. All the elements in set N, Z, Q are real numbers. However, in most of the phenomena, the quantity is needed to have some limitations. Therefore, we introduce a very large number other than a real number is a plus infinity, denoted by plus infinity, whereas a very small number other than a real number is a minus infinity, denoted by minus infinity. Thus, any real number R is between minus infinity and plus infinity, and therefore the set of real numbers denoted by R is defined as R is equal to minus infinity to plus infinity open interval, which is defined as set consisting of elements R such that R is between minus infinity and plus infinity. Further, the set I is defined as R such that R is a real number and R is not a rational number, known as a set of irrational numbers, and is of fundamental importance in sciences. An example of irrational number is the ratio of the circumference of a circle to diameter of the circle, denoted by pi, and another example is the base of natural logarithm, that is the either number, denoted by e. Consequently, the union of the set of rational numbers q and the set of irrational numbers I is the set of real numbers R, that is R is equal to Q union I. Well, see properties of real numbers. Clause under addition. For elements A, B belong to R, we have A plus B also belong to R. That is, sum of two real numbers is also a real number. Commutative under addition. For A, B belong to R, we have A plus B is equal to B plus A. Associative under addition. For A, B, C belong to R, we have A plus B plus C is equal to A plus B plus C. Additive identity. There is 0 belong to R. The additive identity, that is A plus 0 is equal to A, which is equal to 0 plus A for all A belong to R. Additive inverse. There is minus A belong to R. The additive inverse of A belong to R, that is A plus minus A is equal to 0, which is equal to minus A plus A for all A belong to R. Clause under multiplication. For A belong to R, we have A cross B belong to R. That is, product of two real numbers is also a real number. Commutative under multiplication. For A B belong to R, we have A cross B is equal to B cross A. Associative under multiplication. For A, B, C belong to R, we have A cross B cross C is equal to A cross B cross C. Multiplicative identity. There is this 1 belong to R. The multiplicative identity, that is A cross 1 is equal to A, which is equal to 1 cross A for all A belong to R. Multiplicative inverse 1 over A belong to R is a multiplicative inverse of A belong to R other than 0, that is A cross 1 over A is equal to 1, which is equal to 1 over A cross A for all A belong to R other than 0. Distribution of multiplication over addition. A cross B plus C is equal to A cross B plus A cross C for all A, B, C belong to R. Further, the real numbers satisfy the following order properties. For A, B, C belong to R, if A is less than B and B is less than C, then A is less than C. For A, B, C belong to R, with A is less than B, we have AC is less than BC if C is positive. For A, B, C belong to R, with A is less than B, we have AC is greater than BC if C is negative. For A, B belong to R other than 0, with 0 is less than A is less than B, we have 0 is less than 1 over B is less than 1 over A. For A, B belong to R other than 0, with A is less than B is less than 0, we have 1 over B is less than 1 over A is less than 0. That's it for today. Well, in the next lecture we will see some other topic. Don't forget to share, like and subscribe. Easy Math with Dr. Nasir. Thanks for watching.